Hello friends, welcome back to our YouTube channel Maths and Electronics Tutorials. In today's video, we are going to continue the topic of logic gates. In my previous video, I have given the introduction to logic gates. Please do watch that video before watching this so that you can understand this concept much better. So, let's start our topic. As I explained in my previous video that there are three types of gates: basic gates, universal gates and special gates. So in the category of basic gates, the first gate is NOT gate. So let's know about it. Here on the screen you can see the symbol of NOT gate. It is called NOT gate because when we give a input, the output state is not same as the input state. So here you can see I have given the input as A. So the output is A bar, which is the complement of A. So let's understand this through an example. If we give 0, that is low voltage, we get the output as high voltage, that is 1. So input and output are always complement to each other. Hence this gate is also known as inverter. So this is the truth table of NOT gate. First is, if we give input as 0, then we get its complement as output, that is 1. If we give input as 1, we get output as 0. So now let's know about another basic gate, that is OR gate. It is named as OR gate because if input is high, that is 1, then either or both of inputs must be high. If both inputs are low, then the output is also low, that is 0. So here on the screen you can see the symbol of OR gate. In OR gate there are two inputs A and B, and the function of OR gate is y, that is output, is equal to A plus B. So according to this statement, there must be at least one input that must be high to get the output as high. So here you can see 0 0, both inputs are low voltages. So the output is also a low voltage because 0 plus 0 is 0. Next, if we give input as 0 and B input as 1, then we get output as 1 because 0 plus 1 is 1. Next, if we give A input as 1 and B input as 0, then 1 plus 0 is 1. So the output is 1. And next is, if we give both inputs as 1, then also we get output as 1. So here you must understand one thing, that there must be at least one input that must be high, so that the output must be high. If we give both inputs as 0, then our output will be 0. So this is called as OR gate. So our next basic gate is AND gate. Here on the screen you can see the symbol of AND gate. It is called as AND gate because in this input 1 and input 2, that is both A and B, must be high to get the output as high. So if either of them is low, then the output will be low. Here you can understand this through the truth table. See, here the input A is given as 0 and B is also given as 0. So A into B, that is 0 into 0, is 0. So the output is low. Next, if we give input A as 0 and input B as 1, then also 0 into 1 is 0. So again output is low. Next, if we give A as 1 and B as 0, then 1 into 0 is 0. So the output is again low. But if we give input A as 1 and input B as 1, then the output is 1 because 1 into 1 is 1. So the output is high. So in the case of AND gate, both A and B must be high, that is 1, to get the output as 1. So now I hope that you understood about these three basic gates: NOT, OR and AND. So now let's know about universal gates NAND and NOR. So the first universal gate is NAND gate. It is called as NAND gate because it is made up by combining both NOT and AND gate. So here you can see on the screen, this is AND gate. So as we saw above, the input is A and B here, and the output is y is equal to A into B. So to the output of the AND gate, we have added a NOT gate, and the output of NOT gate is it complements the input. So the input here is A into B. So it complemented the input, that is A into B bar. So the output of NAND gate is Y is equal to A into B bar. And this is the symbol of NAND gate. So here through the truth table we'll understand the operation. The inputs are A and B and the output is A into B bar. So if we give the inputs as 0 0, then our output will be 1. That is 0 into 0 is 0 and 0 bar is 1. Next, if we give the input as 0 1, then the output will be 1 because 0 into 1 is 0 and 0 bar is 1. Next, if we give the input as 1 0, then the output is again 1 because 1 into 0 is 0 and 0 bar is 1. Now, if we give the inputs as 1 and 1, then our output will be 0 because 1 into 1 is 1 and 1 bar is 0. Hence, this is the operation of NAND gate. So now, let's know about another universal gate, that is NOR gate. It is called as NOR gate because it is made up by combining NOT and OR gate. So here you can see on the screen, this is the OR gate and this is the NOT gate. This is OR gate with two inputs A and B, and the output of OR gate is Y is equal to A plus B. So the output of OR gate is given as input to the NOT gate, and as you know, the input of NOT gate is complemented as its output. So A plus B is complemented and the output of NOR gate becomes as A plus B bar. So this is the symbol of NOR gate and the output is Y is equal to A plus B bar. So let's understand this through the truth table. Here you can see the two inputs A and B. So if we give the inputs as 0 0, then our output will be 1 because 0 plus 0 is 0 and 0 bar is equal to 1. Next, if we give the inputs as 0 and 1, then our output will be 0 because 1 plus 0 is 1 and 1 bar is 0. Next, if we give the inputs as 1 0, our output will be 0 because 1 plus 0 is 1 and 1 bar is 0. If we give the inputs as 1 1, then 1 plus 1 is 1 and 1 bar is 0. Hence the output will be 0. So in NOR gate, if both inputs are low, then the output will be high. Now, I hope that you understood what are basic gates and what are universal gates. So now let's know about the special gates XOR and Xnor. The full form of XOR gate is exclusive OR gate. It is called as exclusive OR gate or XOR because it gives output as high, that is 1, only when either of the input is high, that is 1. So when both inputs are high or low, it gives 0. So here on the screen you can see the symbol of XOR gate. We give the inputs as A and B and the output will be A B bar plus A bar B. So let's understand this operation through the truth table. So the inputs are A and B. If we give the inputs as 0 0, then our output should be A B bar plus A bar B. So we have first calculated A B bar, that is A into B bar, which is 1. So 0 into 1 is 0. Next, A bar B is 1 into 0, which is again 0. So 0 plus 0, then the output will be 0. Next, if we give the input as 0 and 1, then our A B bar will be 0 because 0 into 0 is 0. Next, A bar B will be 1 because A bar is 1 and 1 into 1 is 1. So the output will be 0 plus 1, which is 1. Next, if we give the input as 1 and 0, then A B bar will be 1 because A will be 1 and B bar will be 1. So 1 into 1 is 1 and A bar B will be 0 because A bar is 0 and 0 into 0 is 0. So the output will be 1 plus 0 is equal to 1. Now the inputs are 1 and 1. So A B bar will be 0, A bar B will be 0 and the output will be 0 plus 0, which is 0. So you have to understand here that it is exclusive OR gate. So either of the inputs must be 1 to get the output as 1. If both inputs are low or both inputs are high, then our output will be 0. So now let's know about another special gate, that is Xnor gate. It is known as Xnor gate because it is made up by combining Xor gate and NOT gate. So here you can see on the screen, this is the symbol of Xor gate with two inputs A and B, and the output of Xor gate is y is equal to AB bar plus A bar B. So the output of Xor gate is given as input to the NOT gate. So as you know, the NOT gate complements the input. So the output will be AB bar plus A bar B whole bar. So through the truth table, let's understand its operation. First, we have taken inputs as A and B. If we take inputs as 0 and 0, the output will be 1 because A into B is 0 and A bar into B bar is 1. So 1 plus 0 is 1. Next, if we take inputs as 0 and 1, then A into B will be 0, A bar into B bar will be 0, so the output will be 0 plus 0, that is 0. Next, if we take input as 1 and 0, then A into B will be 0 and A bar into B bar will be 0, so the output will be 0 plus 0, which is 0. Next, if we take the inputs as 1 and 1, then A into B will be 1, A bar into B bar will be 0, so the output will be 1 plus 0, that is 1. So here you can see that it is exactly opposite to the XOR gate. If we give the inputs as low, that is 0 0, then we get output high, that is 1. Or if we give both inputs as high, that is 1 and 1, then we get output as 1. Now I hope that you understood all types of gates with their truth tables. Thanks for watching this video. Please share your comments through the comment section and like, share and subscribe our channel.